Hi folks, we're working with the electromagnetic induction experiment or simulation this week. If you take a look at the screen, I have the simulation up. We have a bar magnet, there's a coil, and as you can see, there's no time rate of change. There's a magnetic flux passing through the coil, but there's no time rate of change. Okay, we can change the amount of flux by moving the bar magnet, and as you can see, we can even move it up and down a little bit. The bar magnet doesn't even have to go through, and you get a little flicker of current going through. But our biggest, hang on, I gotta get my cursor working here. Okay, our biggest change in electromagnetic flux is when we actually change the direction of the magnetic field. Okay, and so we'll have that. So we're working with electromagnetic induction. Okay, we can. Another, no, we're going to go ahead. Okay, so we have a DC source right here. We have a steady current going through. Again, there's a magnetic field. We could even, let's see if we can pick this thing up. We can change the magnetic field by moving this coil, okay? But inside the coil itself, we don't have any change, okay? And so we would, if we were to put another coil, pickup coil near here, we would have to move this coil around in order to pick up some electromotive force. Okay, almost said something different. Okay, the electromotive force in the other coil. Okay, which is exactly what we have right here. Okay, so we move it around here, and as we do so, as the magnetic field, as it passes through the surface of this coil, perpendicular to that coil, that can cause a time rate of change of the magnetic flux, and therefore an electromotive force which we also call potential, which would drive current in the coil. Okay, this is the one we're working with right here. Here's your coils. You get a little water here on the water wheel. We're changing the electromagnetic field. We can show that field like this. Okay. And I wonder, can we move this? No, we can't really move that. Okay. And we can show a field meter. Yeah, we can take a look at what the field meter is right over here. We have both the magnitude of the B field as well as its X and Y components. Okay. And let's see, here we go. We have a meter here. Notice the meter is not calibrated. The meter is not calibrated, so we're gonna have to figure out what each of these tick marks means. Notice that we have one tick mark here, and then three little tiny ones, and then one big one. Okay, so in other words, that's 0, 1, 2, 3, 4, 5, and all the way here to 10, 15, 20. Okay, and then we can change that. We can increase the field strength. Let's see, we can increase the loop area. Let's see, what else can we do to max this out? Okay, so I'm sorry, I needed to just take a little peek at that, and let's see what we can do with this thing. Okay, so this thing goes back and forth pretty rapidly. And is there a pause button underneath my face right there? Let's I can't really see right the way the recording is going. I can't really see what about right. Nope, no, that's going to pause the recording. Okay, so that's just our general introduction of what we're doing this week. So have fun.